So our goal is to ensure that our value of the amount of money in account A should be 20% higher than what he puts into B. So if there's $100 in account B, then he should put 120 into account A. So how do we get that relationship? Well, if we take B and we multiply it by 1.2, which remember 1.2 is equivalent to 120%. So basically we want to get 120% of what's in B and put that in A. And so there's one relationship. It's a little bit harder to go the opposite way. How do I get B from A? Well, you could say that B is equal to A divided by 1.2, dividing both sides by 1.2 here, but that's not very helpful. So next, let's take a look at one more. The amount of money he puts into A should be 20%, I meant to say lower than what he puts into B. Okay, so 20% lower. What does that mean? So if into B he puts $100, that means he should only put $80 into account A, since that's 20% lower. So in this case, how do I get from A to B? Well, whatever I put into B, in order to get A, I have to basically multiply it by 0.8, because I'm only putting 80% of that amount into account A. Finally, let's actually take a look at a problem. Let's suppose that this puts it all together. So an investor puts money into two accounts, A and B. A pays 5% and B pays 7% per year. For tax purposes, his earned interest should be $500. The amount of money he puts into A should be half as much as what he puts into B, due to risk factors associated with account A. How much should he invest into each account? Well, we already have our two equations that we set up back here. We have that 0.05A plus 0.07B equals 500. Equals 500. And we also have that the amount in A should be half as much as what he puts into B. And we wrote earlier A equals 1/2 B. So now we want to actually solve this. We want to actually visualize, or before we do that, we want to visualize the solution. You know what, we'll wait afterwards. Let's solve this thing first. So we want to basically know the values of A and B. We have two variables, so we need two equations. And by substitution, we've already got this one set up, that anywhere I see an A, I could put in 1/2 B. So I'll have 0.05. Instead of A, I'll put in 1/2 B plus 0.07B equals 500. Now I get to simplify this. I'll isolate B. So 0.05 times 1/2 is going to be, let's see, 0.05 divided by 2, which is 0.025. So I'm going to erase that. I'm just going to put 0.025. Of course, you can use a calculator for that if you'd like. 0.025B plus 0.07B equals 500. Adding the two together, I get 0.095B equals 500. And what I will do next is I'm going to use Wolfram Alpha. I'll talk a little bit more about this site later on. But I just want to do 500 divided by 0.095. And this basically acts as a calculator. If you go to wolframalpha.com, we'll be using this a lot since it's a very powerful tool. So here it gave me an answer of 5263.16. So B is 5263.16. Now I want to get to the hundredths place since that's the number of cents that I'm going to put in. And now that I've used both equations to solve for B, I can plug in this value into either equation and figure out what A should turn out to be. You can test it, put it into both equations, solve for A, and see if you do in fact get the same answer. There might be a little bit of rounding error, but that's about it. So taking half of that should give me the amount to put into A. So I'm going to take 5263.16. I'm going to multiply it by 0.5, or you can do 1/2 in there. And that's going to give me 2631.58. So A equals 2631.58. And there's my answer. That's how many dollars I should put into account A. This is how many dollars I should put into account B. And